Hey everybody, Monty here. Let's wrap up topic 3, this idea of rigid motions. Translate, reflect, rotate. Now, a lot of you did some amazing work when it came to rotations, okay? So be proud of that. At the same time, I want to show you a cool pattern in case you didn't actually look at the actual vertices. So let's start out with this blue triangle, number 1. We're going to rotate 90 degrees and rotate and rotate. Watch what happens. There's a pattern here. As we just drop this down, I think you agree that this shape goes from 0, 2 to 2, 0. This peak from negative 4, 2 to 2, 4. 0, 5, 5, 0. Now, mathematically, can you see how all the coordinates just flipped? Let's do that again. Let's rotate another 90 degrees about the origin. Okay, this point goes here. 2, 0 becomes 0, negative 2. 2, 4. 4, negative 2. 5, 0. 0, negative 5. You see how cool that just rotated? Now, before we actually move this one more time, can you predict what the coordinates will be in the final rotation? Now remember, you can pause the video anytime, but I'm actually going to rotate this up. Okay, so this goes here. Whoop, wrong color. Okay, that goes there. This one's going to go up here. This one's going to go here. Okay, so we're going to draw this in. And I'll bet you had already predicted how 0, negative 2 became negative 2, 0. 4, negative 2 became negative 2, negative 4. And 0, negative 5 became negative 5, 0. Isn't that cool? So even though we were able to rotate, and most of you got the idea of the rotation and sketching it, the actual vertices flip for every 90 degrees. Let's try another one. Okay, now for the honors geometry folks, they're actually doing this on Khan Academy, and they actually use the numbers. But let's just look at this, okay? Just grab a red here, and if we're going to rotate 90 degrees in the positive direction, we're going to take this over here. No big deal. But as we do it, let's actually write the coordinates. 3, 3, flip it, becomes negative 3, 3. Okay, that was easy, and we'll call that A prime. So A prime becomes negative 3, 3. Now let's look at R. R. This R has to go way out here, but I'll bet you negative 7, 5. We flip it. Negative 7, 5. And because the coordinate changes because we go to this quadrant here. So let's go to negative 7, positive 5, and it'll be negative 7, 5, and that's going to be R prime. Okay, let's do M. Let's flip it, 5, 7, but it's going to be in the new quadrant, so negative 5, positive 7, negative 5, positive 7, and this will be M prime. Negative 5, positive 7. Last one. 5, 1. 5, 1 is going to have to go up high, isn't it? So negative 1, 5. So my whole goal was to just show you that there is a pattern also in the numbers. So -1, +5, -1, +5. And that's going to be y prime. Let's sketch this in. Boom, 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 boom. See how each coordinate rotated 90 degrees? But we can do it numerically with the vertices by seeing the pattern. All right, so I wanted you all to see that as we wrap up this unit, because we don't have enough time to do a lot of these, because this alone was, what, 6 minutes, just this one problem. At the honors level, hopefully this was helpful. The rest of class today, we're going to be wrapping up by recognizing in a multiple choice type quiz, can we identify which transformation happened? Was it a translate? Was it a reflect? Was it a rotate? All right, and then our final activity as we go into the holidays will be kind of an inspiration where I share a little bit about me and the fact that in my family, we're real big on New Year's resolutions and trying to set goals for ourselves for the future. And don't forget tomorrow, our last fun day of math. See you in class. Merry Christmas, everybody.